So this is the long-term trends of Point Pleasant Park forest ecology after Hurricane Juan. So Hurricane Juan was a Category 2 hurricane that devastated Atlantic Canada on September 29, 2003. The hurricane formed in the southeast of Bermuda and got up to 145 kilometer per hour wind speeds. Juan created around $100 million worth of damages, and within all that chaos, it also took out 70% of the trees that were in Point Pleasant Park. Point Pleasant Park is a large forested municipal park that sits at the tip in the south of Halifax and is enjoyed by hikers, dog walkers, and many more people. Today, we are here to discuss the aftermath of Hurricane Juan, touching on topics such as how the overall forest community changed over time, how the density of the dominant species changed after Juan, how has the chosen community metric changed over time, and also predictions towards what we think will occur once Point Pleasant Park moves towards its community climax. So, according to McDonald 2017, Halifax is known as Kijaptuk to the Mi'kmaq community and holds an incredible cultural significance. Point Pleasant Park is recognized by the Mi'kmaq Nation as Adnapnakuti, which translates to spirit place, which holds a lot of spiritual significance. This land was the place where the Mi'kmaqi would come together for 7 days after the first full moon during the frog croaking month, which occurred in the springtime. Given the invaluable resources and spiritual significance of Point Pleasant Park, the Mi'kmaq community fiercely protected these lands as they recognized how vital they were for protection and spiritual enlightenment. And then for each question that we're going to be answering, the null hypothesis states that there's no significant relationship with the variable being observed. And then in contrast, the alternative hypothesis state that there is a significant relationship.
So to begin the study, 6 20 by 20 meter study sites were chosen in areas that were deemed to have the highest impact on forest structure from the hurricane. These sites acted as replicates for the data that was collected from 2004 until 2023. Due to extenuating circumstances where data collection was not possible, the years 2005, 2007, 2016, and 2020 were excluded from the study. There were two main measurements utilized within the study. Tree density, which was taken as a measurement per species per 400 meters squared site, and tree size, in which DBH was utilized as a method to estimate the amount of wood per site using a 30-meter retractable measuring tape. This method was used as it allowed for comparison of the results to logging industry data, since DBH is a standardized measurement of the logging industry at a height of 4.5 feet. The species of tree were determined using the Canadian Field Naturalist by Rowland and Smith 1963, and the identification of Nova Scotia woody plants in winter by Donnelly 1960. Linear regression was utilized for the statistical data analysis, as it helps to quantify and identify trends and relationships between variables over time, while allowing for hypotheses to be deemed significant or not. If a dataset is deemed to have a significant linear relationship, it can be utilized as a predictive method for the relationship between the variables. Within this study, there were three main questions posed. How has the overall forest community changed over time? What can you predict will happen to the overall community as the forest moves towards its climax community? 2, how has the density of the dominant species in 2004, as well as the dominant species in 2023, changed over time? What can you predict will happen to the dominant species as the forest moves towards its climax community? And 3, how has the chosen community metric changed over time? What can you predict will happen to the chosen community metric as the forest moves towards its climax community? This presentation aims to answer these questions based on provided data and regression analyses to better understand the secondary succession of Point Pleasant Park. The changes in overall forest community can be observed through trends depicted in total density, Shannon Diversity Index, and DBH graphs. Total density of the 6 400-meter squared replicates demonstrated a significant increase from 2004 to 2023, and there was found to be a strong correlation between total density and the time after the hurricane. This increase shows that the regrowth of trees after devastation posed by Hurricane Juan. There are multiple ecological mechanisms that are possible contributors to the change in density of trees over time, including soil composition, sunlight availability, and temperature. With regards to soil composition, it was noted that there was no significant changes observed from the intact and disturbed sites. This was found by Burley et al. 2008, and therefore it could be ruled out that as a factor contributing to the changes of total density. Also, according to Burley et al. 2008, Point Pleasant Park has seen an increase in dominance of fast-growing pioneer species. Therefore, the density could be attributed to the presence of fast-growing species. The Shannon Diversity Index has demonstrated a significant positive relationship from 2004 to 2023, with a strong correlation between the index and the time after the hurricane. Since this measurement is calculated by the number of species present in proportion to the species abundance and relative to the total abundance of all species in the community, the increase shows that the forest community diversity is increasing in an even manner. Due to the loss of trees from the hurricane, the diversity of species plummeted as only the trees that were able to withstand the extreme weather were able to survive. During regrowth, the increase in the diversity of species could be attributed to the presence of native and non-native species within the study sites. According to Burley et al. 2008, majority of the non-native species that were found within these sites had also been noted within the reference plots, meaning that these species were present before the storm and therefore contributed to the increasing diversity over the 2 decades. From the data taken from Point Pleasant Park, the DBH has also demonstrated a significant decrease from 2004 to 2023, with a moderate correlation between DBH and time after the hurricane. From the data, we can see that the DBH was significantly higher during the range from 2004 to 2008, until there was a decline where the measurement remained relatively stable until the latest data in 2023. This trend could be attributed to the large standing trees within the park that were able to withstand the extreme weather conditions, while all the other trees were wiped out. Then in the following years, due to the changes in the community and exposure, these trees likely did not survive, and therefore only the smaller regrowth trees contributed to the DBH. As the forest reaches its climax community, I predict that the overall community will see a stabilization in both density and diversity, with a positive trend will be observed in DBH. I believe that the diversity will stabilize as there are only so many species that will grow within the conditions of the park, and while we are seeing an increase during the regrowth phase, that this will only remain until the seeds that are within the soil grow. Similarly, the density will also stabilize during the climax community period, as the forest will only be able to maintain its equilibrium at a certain density to avoid competition for nutrients, sunlight, and space. In contrast, I believe that as the forest grows, the overall community will demonstrate an increase in DBH as the trees grow over time.
Prior to the devastating impact of Hurricane Juan, the red spruce and red maple trees reigned supreme as the dominant species of Point Pleasant Park. Their dominance proved to be an asset during the regeneration process following the damages caused by the hurricane. Red spruce, known for its proficiency in regenerating amidst decaying wood, found the aftermath of Hurricane Juan to be the perfect environment for regeneration, said by Dumas and Prevost 2007. Also, red spruce possesses the remarkable ability to germinate in low light conditions, which enables them to regenerate in inaccessible areas to the other organisms. These adaptive advantages give reason to why red spruce reigned dominant for so long and was able to regerminate efficiently after the catastrophic event. On the other hand, red maple exhibits 2 distinct methods of regeneration, one through seedlings and the other through clonal sprouting from stumps following a forest disturbance just like this one, said by Ostrowski and Ashton 2022. This dual approach to regeneration gave red maple trees a competitive edge over the organisms after the hurricane, as they possess multiple ways to repopulate their community. Said by Burley et al. 2008, the soil, though affected, retained its fertility after the hurricane in Point Pleasant Park, which also allowed these dominant species to continue their growth even in the face of environmental challenges. The process of natural regeneration is clearly depicted in figures 4 and 5 above, which shows a constant increase in tree densities in the years subsequent to the hurricane. Both the red spruce and red maple trees yielded p-values below 0.05, prompting the rejection of the null hypothesis and affirming a positive correlation between the densities of the dominant species and the time after Hurricane Juan. However, it is necessary to acknowledge that the strength of this relationship, as shown in our R values above, appears to be weak. Thus, while there still exists a statistically significant relationship between densities and time following Hurricane Juan for both red spruce and red maple, it's necessary to note that the correlation is modest, showing that the densities do still in fact increase, but the rate of increase may be slow or inconsistent following the damages from Hurricane Juan. As Point Pleasant Park moves towards its climax community, I believe that red spruce and red maple will continue to be the dominant species among other organisms. I believe this due to their resilient abilities. Both red spruce and red maple possesses abilities that allow them to continue to thrive even in the face of environmental challenges. The shade tolerance ability in the red spruce gives them an upper hand as they are well suited for almost all environments that surround them, and red maple yields many different ways of germinating that allow them to reestablish their community efficiently after a catastrophic event.
Palu's evenness index is a measure of how species are evenly distributed in a community. Palu's index has been steadily decreasing since Hurricane Juan in 2004. There's been a significant negative relationship between 2014 and 2023, prompting us to reject the null hypothesis that there has been no significant decrease in Palu's index between 2004 and 2023. Palu's index is expected to further decrease over time as red spruce and red maple will continue to dominate other species, and this will drive down the evenness index in Point Pleasant Park. In conclusion, Hurricane Juan had a huge immediate impact on the trees in Point Pleasant Park, destroying up to 70%. This presentation looks to discover the impact Hurricane Juan had on two of the most common tree species from the immediate impact of the hurricane in 2004 up to last year, 2023. It's clear that there is a significant increase in total density of both the red spruce and red maple trees between the immediate impact of Hurricane Juan in 2004 and 2023. This can be used to assume that Point Pleasant Park is in its intermediate species stage of secondary succession, as there is an increase in total density while also having a decrease in DBH. Being in an urban environment, it is possible that this could affect the succession due to reasons such as management practices and altered environmental conditions.
So question 1 states, are there strategies to help support a faster succession time after an ecological disturbance? If so, what are they, and how would these techniques work to increase the regeneration rate of the tree population? Is there a limit to human interference in the natural recovery? What is it and why? Some strategies presented by Vesser 2012 that help support a faster succession time include reintroduction of native species by seed or young tree planting, while controlling the presence of invasive species. Also, soil treatments to improve nutrient depletions that may have occurred. These strategies work to increase the rate of recovery as reintroducing native species allows researchers to ensure that these trees will grow in the area. Providing soil treatments ensures that the newly growing trees have the required nutrients to grow, as some disturbances may change soil compositions, impacting the nutrient deposits in the region. Human interference is good in some cases, but there is a limit. As previously mentioned, the introduction of native species can pose benefits to recovery, but without careful consideration, it can also impede on the diversity of the region. Since ecosystems are very complex in the ways they function, there are also a lot of unknowns about how a community will react to such human intervention.
The second question states, do you think the park was opened up too soon or too late following the hurricane? Would leaving it closed longer help the park recover more, or does that cause more damage by not allowing it to adapt to people being in it early on in the process? What ecological processes may be most impacted by the presence or absence of humans in Point Pleasant Park? So following Hurricane Juan, Point Pleasant Park was closed for 9 months and reopened once the park was deemed secure for both regeneration and public use, said by Point Pleasant 2008. By waiting for an extended period before reopening, ecologists were able to minimize the damages that would be caused by human presence if the park was open too soon. This timeframe also gave the park ample time to begin the regeneration process uninterrupted. In the absence of humans, vegetative and wildlife success would bloom as they would no longer be the subject to human activities like trampling and habitat destruction. This may be a park, but I can certainly understand how most forests and animals would thrive without the presence of humans.
Question 3 is, how does the Shannon Diversity Index contribute to our understanding of the species biodiversity that lives within Point Pleasant Park? What specific insights does this index provide us with that would assist us in ecologically restoring this environment properly? Can these findings from Hurricane Juan be used to inform management practices in Point Pleasant Park? The Shannon Diversity Index is an essential measure used to quantify the biodiversity of a given area and can contribute to our understanding of Point Pleasant Park following Hurricane Juan in a few ways, one being the assessment of biodiversity loss. This information is crucial to understanding the damage done by the hurricane and can give us a clearer picture of what our conservation efforts should prioritize. Using the Shannon Diversity Index, environmental managers are able to learn which efforts they're putting in place are making the best improvements towards biodiversity. By integrating the information gained from the Shannon Diversity Index into environmental rehabilitation practices, managers can be more confident in their efforts to restore the former environmental health and future resilience of Point Pleasant Park.
We would like to give thanks to Christine Beauchamp and her students for beginning this research and their efforts in collecting the data from Point Pleasant Park. We would also like to extend our thanks to Allison Schmidt for her contribution to the research and the preparation of the data, and Neve Murley for providing feedback during completion. Additionally, our peers who provided feedback are also recognized in the contributions to our project.